So in this question, we have two people and they are sitting on a rowboat and they're sitting at two sides of it, and then all of a sudden they start to change seats and we ask how far in what direction will the boat move. So first let's draw this graph. We have two people. Assume this is a boat. We have one person of 85 kilograms sitting on it, and we have another person of 55 kilograms sitting on it. And the boat itself has mass of 58 kilogram in the center. So we can kind of expect the center of mass to be somewhere over here, because this person is 85 is heavier than the other. So what happens after the exchange of seat is that the center of mass will not move because it's an isolated system. But now the 85 kilogram person will be here, and the 55 kilogram person will be here. So this configuration will change into 85 kilogram. So it's here, 55 kilogram person is here, and this is a 58 kilogram center of mass of the boat. So yes, so then what we're asking is how much distance is between here. And this is a result of the center of mass staying stationary. Okay, so before we think about the second case, let's first look at the original case and let's first figure out what this distance will be. And this can be done by just calculating the center of mass in the normal way. We have center of mass equals, and I'll just call it ABC, MAXA plus MBXB plus MCXC over MA plus MB plus MC. Okay. So now we plug in all the numbers. We have 50. I'm ignoring the 55 because I'm taking that to be the origin. So it's 58 kilogram times 1.5 meter because it's the center of the boat, plus 85 kilogram times 3 meter divided by 198 kilogram. That gives me 1.727 meter. So that is a distance of the center of mass with respect to the leftmost side. Okay. Now we need to figure out how far it is from after the exchange of seat. So there are a couple ways we can do this. So one way I like is to just look at this graph and to utilize the property of symmetry. Because if we look at this graph, before and after the exchange of the seat, these two graphs, they are symmetric. So what that means is that if this distance is 1.727 meter, then this distance will also be 1.727 meter. So this is 1.727, and this is also 1.727, and then at the same time we know that the length of the boat here is 3 meters. So how far will the distance be? If we call it d, d is simply 2 times x of center of mass minus x of the boat. So this is equal to 2 times 1.727 meter minus the length of the boat is 3 meter. So this gives us a distance of 0.454 meter. So that is D. And there are other more complicated ways of doing it, but I think looking at this graph and utilizing symmetry is the simplest way to derive the 0.454 meter. So the answer to this question is that the boat will move 0.45 meter towards the initial position of this 85 kilogram heavier individual.